Planets and stars, a common phenomenon. Planets are almost as common as stars in the galaxy. Among the hundreds of billions of stars in the Milky Way, a significant portion have gravitationally bound systems of planets orbiting them. While many of these planets differ radically from ours, they share key characteristics that offer insights into their formation. Understanding the life cycles of stars and their planetary systems provides crucial knowledge about the mechanisms that led to their creation. With this understanding, we are finally beginning to unravel the events that marked the birth of the solar system. ### the solar system today. Before exploring the solar system's origins, it's essential to understand its current structure. Today, the solar system is approximately 4.5 billion years old, with 8 known planets. These include 4 smaller, rocky terrestrial planets close to the Sun and 4 larger gas and ice giants farther away. 6 of these 8 planets host at least one moon, with the largest planets having dozens. Some moons are so massive and geologically complex that they could be considered worlds in their own right if not for their gravitational captivity. Beyond planets and moons, the solar system contains dozens of dwarf planets, millions of rocky asteroids, and trillions of icy chunks arranged into bands and belts. Outer regions. The solar system's outer regions consist of the Kuiper Belt, starting just beyond Neptune's orbit. It extends to about 55 astronomical units, AU. The scattered disk, reaching distances over 100 Australian dollars. The hypothetical Oort cloud, stretching from about 600 Australian dollars to over a light-year into interstellar space. For reference, 1 Australian dollar is the distance from Earth to the Sun, approximately 150 million kilometers. Inner features. Most interesting features, including the rare presence of life, are concentrated within about 50 Australian dollars of the Sun. This region is shielded from harmful interstellar radiation by the Sun's heliosphere. Today, the solar system exists in a peaceful balance. Its 8 planets follow near-circular orbits, with the rocky planets inside and gas giants farther out. However, since the discovery of exoplanets in 1995, we've learned that such neat arrangements are rare. Other planetary systems often exhibit dynamic, chaotic structures. Formation of the solar system. The solar system's formation began billions of years ago in a massive molecular cloud. This cloud fragmented into smaller pockets of gas, each forming protostellar nebulae. The solar nebula, where our solar system originated, was one such pocket. The nebular hypothesis. This widely accepted model suggests that star systems form when a trigger event ***, such as a nearby supernova, generates a shockwave that sets a molecular cloud in motion. Angular momentum causes the cloud to collapse, rotate, and flatten into a disk. Accretion disk formation. Dust and gas in the disk coalesce into a star at the center, while planets form from the remaining material. Star formation. In the heart of the solar nebula, gravity pulled gas and dust together to form the Sun. This process took about 100,000 years, during which a hot, dense core emerged. Over time, this core ignited, creating a protostar. The surrounding accretion disk continued to feed gas into the growing star, while jets of gas from the protostar's poles cleared the remaining material. Eventually, the Sun reached a stable state, entering its main sequence phase. Planetary formation. Planetary formation window. Planets form during a brief 10 million year window when conditions in the protoplanetary disk are ideal. Terrestrial planets, rocky planets like Earth, form closer to the star, where it's too hot for volatile substances like water to condense. 2 gas giants, beyond the snow line, around 5 Australian dollars, volatile ices accumulate, creating massive cores that attract hydrogen and helium, forming gas giants like Jupiter. Ice giants Uranus and Neptune are thought to be failed gas giants, retaining thick layers of volatiles but lacking significant hydrogen and helium. As planets form, leftover material collects into asteroid belts and icy regions like the Kuiper Belt. The birth of the solar system. The Sun's formation began with the gravitational collapse of the solar nebula, triggered by a nearby supernova. Heavy elements from the supernova enriched the solar nebula, setting the stage for planet formation. Within a few million years, planetesimals formed from dust grains in the protoplanetary disk. These grew into planetary embryos, colliding and merging to form the planets we know today. The unique story of the Solar System. Unlike many chaotic star systems, the Solar System's planets eventually settled into stable orbits. Over billions of years, this allowed Earth to develop life, a phenomenon so rare and complex that it's capable of pondering its own origins. The story of the Solar System, from its violent beginnings to its serene present, is a testament to the intricate processes that shape the universe. ####The formation of Jupiter. The first planet of the Solar System to form was Jupiter. It began as a massive planetary core, drawing in early hydrogen and helium atoms from the surrounding protoplanetary disk. Within about 100,000 years, Jupiter's core reached a mass over 150 times that of Earth. It was the first planet to witness the sun rise on the horizon. Jupiter formed approximately 3 million years after the Solar System began. As it grew, it had access to an abundance of dust in the protoplanetary disk. This material accretion caused Jupiter to shift slightly inward, veering off its orbital path and spiraling closer to the Sun. The young Jupiter plowed through the protoplanetary disk, clearing vast swathes of material and growing significantly larger than all the other planets. Today, Jupiter is around 320 times the mass of Earth and weighs more than all the other planets combined. The rise of Saturn, Uranus, and Neptune. Saturn began to form shortly after Jupiter, coalescing from the dust around the snow line. However, it lacked the iconic ring system we see today. Despite being similar in size to Jupiter, Saturn is much lighter, as Jupiter had already consumed most of the available material. Following Saturn, the ice giants Uranus and Neptune began forming. By this point, the young sun's emissions had scattered much of the remaining hydrogen and helium gas. This explains why the ice giants are significantly smaller than the gas giants. However, the positions of Uranus and Neptune in the current solar system present a mystery. There wasn't enough material in their distant regions to form such massive planets. This suggests that Uranus and Neptune formed closer to the Sun, possibly between the orbits of Saturn and Jupiter, and later migrated outward. The formation of terrestrial planets. In the inner solar system, planetary formation resulted in 50 to 100 Moon-to-Mars-sized planetary embryos. These embryos collided and merged in chaotic interactions, a natural selection of planets. Mercury, for example, is believed to have suffered a catastrophic collision with another planetary embryo. This event likely stripped Mercury of its outer mantle, leaving it a dense core. Further from the Sun, Venus, Earth, and Mars followed a different fate. Collisions among planetary embryos caused their cores to heat and allowed them to grow into planets with internal layered structures, magnetic fields, and geological activity. These processes protected their early atmospheres. The terrestrial planets took around 50 million years to complete their formation, as the young Sun transitioned into a hydrogen-fusing yellow dwarf. Planetary migration and the solar system's sculpting. Jupiter and Saturn eventually fell into a 2:1 orbital resonance, with Jupiter completing 2 orbits for every 1 orbit of Saturn. This resonance caused significant gravitational shifts, ejecting Neptune and Uranus to their current distant positions. As Neptune moved outward, it disrupted the Kuiper belt, scattering objects into the outer solar system or ejecting them entirely into interstellar space, forming the Oort cloud. Closer to the Sun, this gravitational reshuffling impacted the asteroid belt. Once densely populated with enough material to form 2 to 3 Earth-sized planets, the belt was thrown into chaos. For 300 million years, asteroids bombarded the inner planets in an event known as the Late Heavy Bombardment. These asteroids, along with icy comets, brought water to the terrestrial planets. Water and the birth of oceans. As the chaos of the early solar system subsided, icy comets delivered water to the inner planets. This water vaporized on impact but remained within the planets' atmospheres. Over time, as the planets cooled, the water condensed into rain, filling basins and creating oceans. Earth, Venus, and Mars once harbored vast amounts of liquid water, making them blue planets during their early histories. 3 water worlds: Earth, Mars, and Venus. While Earth is now known as the blue planet, both Mars and Venus were once similar. Mars had liquid water flowing on its surface, leaving evidence of weathering and erosion. However, being the smallest of the three, Mars cooled quickly, losing its magnetic field. This allowed solar winds to strip away its atmosphere, leading to the evaporation of its oceans. Mars likely retained habitable conditions for only a few 100 million years. Venus, on the other hand, retained its habitable conditions for over 2 billion years. Positioned at a distance analogous to Earth's, Venus once supported temperate climates and liquid water. However, as the sun grew hotter, Venus's oceans evaporated, triggering a runaway greenhouse effect. This process thickened its atmosphere, leading to the boiling away of all water. Today, Venus is a hostile, scorching planet. Earth, a unique oasis. Earth remains a standout success story, maintaining temperate conditions for billions of years. Its distance from the sun and the presence of life processes have helped preserve its climate and atmosphere. However, the fates of Venus and Mars serve as stark reminders that balance cannot last forever. The future, an age of change. While the sun is stable today, the solar system is headed for an age of change, destruction, and evolution. New worlds and stories will emerge, but Earth's time as a thriving oasis will eventually come to an end.